Hello class, today we're going to be looking at graphing quadratics instead of absolute value. This time we'll be using a lot of the same rules that we used before though. Before we even get started with quadratics, I just want to review our parent functions, that way you do not forget, so go ahead and pause the video, see if you can graph these two, and then unpause it to see if you got it right. Alright, hopefully you did well. As we're looking at this, the key thing about a parent linear function is that its slope is 1 over 1 and its y-intercept is 0, 0. So I started here, went up 1 over 1, and went down 1, backwards 1. An absolute value looks like a V, so it has a vertex. The vertex is at 0, 0, and the rate of change is positive 1 and negative 1. Keep those things in mind. You got to keep on studying those things so you do not forget. Now let's look at the parent quadratic function. This guy is a little bit different. Do you remember the basic shape of a quadratic looked like? Hopefully you do. It looked like the letter U, or an upside down U. One of the two. So its rate of change is not constant. Because it's not constant, we can't use slope or anything like that. We have to make a table. So we're going to make a table here, an XY table. Remember, when you make an XY table, you get to pick the X values. You want to pick some X values from over here and some from over here. So we're going to pick -3, -2, -1, 0, 1, 2, and 3. I'm picking these numbers. You get to pick them when you do it. And go from there. So when I plug in -3, I'm plugging in -3 into the x. So it would be y equals -3 squared. When you type this into your calculator, if you have to, you must use parentheses around the -3. You cannot type it in like this. And you cannot type it in like this. Oops. These answers, if you type these in, you will get the wrong answer. So don't do that. Okay? You must type it in like that. And if you do, you get 9. Hopefully you can kind of do it in your head though. -3 times -3 is positive 9. Again, if you're typing your calculator, you must type it in like this. But -2 times -2 is 4. -1 times -1 is 1. 0 to the second power is 0. 1 to the second power is 1, 2 to the second power is 4, 3 to the second power is 9. This is a property of quadratics that you're used to, a repeat. Okay? I start to repeat, so as I graph these, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All I did was plot these points, because that's what these are. These are a bunch of points, a bunch of solutions. I plotted them on the graph. And I can see that it's not straight lines. I can't take my line tool and draw a line. I'll miss it there, or I'll miss the other ones there, so it's not a V. In a problem like this, I have to do curved parts. And it's a little bit harder for me to do it than it should be for you on paper. But they are curved. So that's your parent function. Let's write down the key parts to this. The first thing is, where is the vertex? Just like an absolute value, a quadratic has a vertex. It's right where it starts to change directions. Just like in an absolute value, it's 0, 0. That's the key part. The difference between a quadratic and an absolute value is I do not have a constant rate of change. I went up 1, and then I went up 3, and then I went up 5. So this is what I need to remember about the quadratic, is its vertex is 0, 0. So now let's look at something when I added a number on the outside. The same is true for linear, and the same is true for absolute value. When you add a number on the outside of the exponent, so I've got x squared plus 4, if you remember your rules from absolute value, that is a shift up 4. So if my vertex was at 0, 0, and I went, and this is the parent function right here, and I went up 4, my vertex is now at 0, 4. Now I have to make a table. Okay? I want to plug in numbers to the left of 0 and to the right of 0. So when I plug these in, I'm going to first type in the -2. I've got to put that -2 in parentheses. Here was the function we're graphing, plus 4, which is 8. And I'm going to plug in -1. And I will get 5. You can type that directly into your calculator, just like that. Parentheses, -1 squared plus 4. And you'll get 5. If I plug in 0, I'm going to get 4. And if I plug in 1, I'm going to get 5. If I plug in 2, I'm going to get 8. What do you notice about the table again? Yes, it repeats. So I've got -2, 8, -1, 5, 0, 4, 1, 5, and 2, 8. And then I can graph it as a U. Okay? So if I can remember my parent function is at 0, 0, this tells me to go up 4, then I can make a table, a smart table. I don't have to pick too many values. What do you notice about this problem? Here, my number is being subtracted on the inside of the squared. So if it's on the inside of the square, if you remember your rules, that shifts it to the right 6. So here's my parent function right here in blue. I'm going to go to the right 6. So my vertex is at 6, 0. I got to make a table. But this time, 6 is the middle. That's the vertex. That's the middle of the graph right there. So I'm going to plug in a couple numbers to the left, such as 4 and 5. And I plug in my vertex, and I want 7 and 8. You plug in the numbers a little bit to the left of the vertex and a little bit of numbers to the right of the vertex. Here's my function. I'm going to plug in the number 4 first. If you do that, you will get 4. And I'm going to plug in the number 5. And if you do that, you will get 1. So I get 4, 4, 5, 1. If I plug in 6, I get 0. If I plug in 7, I get 1. 4, again, notice that it repeats. If you're starting to pick up on this, all you really have to do is plug in half of these numbers and just repeat it on the other side. So 4, 4. Let's see. 5, 1. 7, 1. 8, 4. And there's your graph. You can see that it got shifted to the right 6. Finally, one more. What do you notice? Hopefully, you notice that I have both a horizontal and a vertical shift. Using your rules for absolute values, adding 3 on the inside is shifting to the left 3, and subtracting 5 on the outside is shifting down 5. So if I go left 3, down 5, my vertex is at -3, -5. What do we have to do next? We have to make a table. Okay? So when I make a table, tables work for all functions. They definitely work for quadratics. My vertex is at -3, so I want to plug in -4 and -5, -3, and then -2 and -1. Again, you only have to plug in the first 3 if you want to, but x plus 3 squared minus 5. I'll plug in negative 5. Get that, that is negative 5 plus 3 is negative 2, squared is 4, minus 5 is negative 1. Again, this is important for you because you can type this in directly into your calculator. Okay, you don't have to do any mental math. You can type that into your calculator. So negative 5, negative 1. If I plug in negative 4, I'll get negative 4. If I plug in negative 3, I will get negative 5. And then I'll get negative 4. And then I will get negative 1 again. So as I go to plot these points, negative 5, negative 1, negative 4, negative 4, negative 3, 5, negative 2, negative 4, negative 1, negative 1. And you can see this nice, beautiful quadratic again. And if you're looking at your shift, you can see what it took to get from this vertex to this vertex. I went left 3, and then I went down 5, just like these numbers told me here. Alright, so horizontal and vertical shifts. Here's what quadratic functions look like. This is the parent function. And then we have this. Sometimes we can add or subtract numbers on the inside, and sometimes we can add or subtract numbers on the outside. Okay? If we're on the inside, again, rules are the same. Inside, if I add on the inside, I go to the left. If I subtract on the inside, I go to the right. If I'm on the outside, if I add on the outside, I go up. If I subtract on the outside, I go down. Same rules as absolute values. Okay. Then the key is we must make a table. Okay, must make a table to finish the graph. One more before I let you guys go. We're going to look at this one and try to write our own equation. The first step is to describe the transformation. Well, if we remember, our parent function has a vertex that's right here. This guy's vertex is right there. So what did we do? We went right 6, and then we went up 3. We went right 6 and then up 3. If you remember those rules that we just had, right 6 means that we change the inside number. So I have to subtract 6 squared, because it's quadratic, and then up 3 is a plus 3. I don't need to change the steepness. The steepness of this graph is about the same as all the others. So that's how I can write an equation, is I can look at the vertex. Last problem, I'm going to want you to pause the video here, do the last 2 problems the best you can. They should follow exactly like the examples we've done. And then when you're finished, you can unpause. Alright, if I look at this one, this is on the outside, so I go down 4, puts my vertex here. So once I put my vertex there, I plugged in 2 numbers to the left, 2 numbers to the right. You can plug in more if you'd like, but that was enough. Over here, I had to go to the right 4, because this was on the inside, down 7, because it was on the outside, so that puts my vertex at 4, negative 7. Because my vertex is here, I pick a couple numbers to the left, so I plugged in 3 and 2, and I also plugged in 5 and 6. Here's my table, and I graphed it.